In a remote corner of the coastline, behind layers of security and towering steel walls, lies one of the most advanced industrial facilities on Earth, a place where the world's most powerful submarines are born. Today, we take you inside this colossal manufacturing complex, a hidden world of technology, precision, and engineering on a scale few people ever get to see. From the moment the sun rises, thousands of workers and machines move in perfect harmony. Their mission, to build a vessel capable of diving deep into the unknown, surviving crushing pressures, and operating silently beneath the ocean's surface. This is the making of a mega submarine. Every submarine begins with a foundation of extraordinary materials. Sheets of titanium alloy, specially engineered to withstand immense pressure, arrive in massive shipments. Inside the foundry, molten steel glows like liquid fire as it's poured into molds that will later become the submarine's armored shell. Here, precision is everything. Quality inspectors use lasers, scanners, and robotic sensors to check every millimeter of metal. Not a single flaw is acceptable, because at 1,000 meters below the surface, even the smallest imperfection could become catastrophic. Inside the main assembly chamber, a hangar large enough to hold several commercial aircraft, the real transformation begins. Huge cylindrical hull sections are built one by one, rotated on giant platforms, and welded by robotic arms that work with near-perfect accuracy. Sparks flood the air as metal meets metal. Teams of engineers align massive modules using hydraulic tools, merging them into the recognizable shape of a submarine. Inside the hollow frame, steel ribs form the internal skeleton, the backbone of the vessel. Every piece is designed to carry enormous pressure once the submarine descends into the deep ocean. While the outer hull takes shape, an entirely different world is being created inside. An intricate maze of pipes, electrical cables, and ventilation systems fills the corridors. Specialists install advanced sonar equipment, navigation units, propulsion components, and miles of wiring that connect every system together. The control room, the brain of the submarine, is carefully assembled with panels of switches, screens, and monitoring instruments. This is where the captain and crew will make decisions that may determine the fate of missions far from the surface. Modern submarines are not just machines, they are floating supercomputers. In the electronics bay, engineers synchronize communication systems, radar interfaces, and automated safety protocols. Digital maps, tracking consoles, and combat systems come to life as software teams program the submarine's artificial intelligence support systems. Robots install powerful battery modules, providing the vessel with energy needed for long, silent operations. Every component is scanned, tested, and calibrated with scientific accuracy. Now the submarine moves into the finishing stage. In a giant paint chamber, robotic sprayers apply a matte black coating designed to absorb sonar waves and minimize detection. Fins, rudders, sensors, and the iconic periscope are carefully mounted. Outside, structural engineers perform pressure tests, simulating the extreme forces the submarine will face deep underwater. If it survives these tests, it's nearly ready for launch. Now the submarine moves into the finishing stage. In a giant paint chamber, robotic sprayers apply a matte black coating designed to absorb sonar waves and minimize detection. Fins, rudders, sensors, and the iconic periscope are carefully mounted. Outside, structural engineers perform pressure tests, simulating the extreme forces the submarine will face deep underwater. If it survives these tests, it's nearly ready for launch. Back inside the factory, teams begin the final integration. They activate electrical networks, run engine diagnostics, and test emergency protocols. Laser-guided robots calibrate sensitive components, ensuring everything responds instantly and accurately. And then, for the first time, the submarine lights up from within. Screens glow, panels activate, engines hum quietly in the background. This is the moment when the submarine begins to feel alive. It's time for the vessel to leave the assembly hall. Giant transport machines slowly move the submarine toward the dock. Workers walk alongside, guiding its movement with precise hand signals. As the massive hangar doors slide open, daylight hits the hull for the first time, a powerful moment that marks the end of construction and the beginning of ocean testing. At the dock, cranes lower the submarine into the sea. It floats silently as technicians observe every parameter: buoyancy, balance, power distribution. Engines ignite, sending ripples across the water. Sonar systems emit their first test pings, echoing through the deep. The submarine moves forward, slow and steady, beginning the first of many sea trials that will push it to its limits. After months of assembly, testing, and refinement, the submarine is finally ready. The crew boards, systems engage, and the vessel glides across the surface before diving beneath the waves. The ocean embraces it, and just like that, a new chapter begins. Silent, powerful, and engineered for the most demanding missions on Earth. This mega submarine now disappears into the deep, carrying the legacy of every person who built it.
We did it.